knowing how your facade performs all the time, right? So really, facade performance, real-time sensors, sorry, that's really what I'm here to talk about. So the role of the architect today is more complex than ever. As you know, and we all talked about risks and whatnot, but we got to look at the climate. We look at thermal performance, energy comfort. We look at material science. We look at air quality, chemical hazards, all sorts of issues, environmental responsibility. We've got contractual issues. We've got costs. We've got all sorts of things, right? So that's the question. However, over the life of the building, what we're saying is how much do we really know how your envelope really performs and how it actually meets the design specification. So really how it starts, I guess, in the design phase is the mechanical engineer will always assume something, right? When he designs the system, the lighting and whatnot, he'll go, all right, we're going to lose so much energy, or we're going to get so much energy from the north, south, east, west. We look at how the facade performs in terms of U value, solar heat gain coefficient, heat loss, heat gains, and so on and so forth. They also assume there's an air infiltration that goes through the facade, and they accommodate it with air changes and whatnot. So, plus occupancy and usage, and allowing for additional changes and whatnot. So the design accommodates an assumption as usually an allowance, and normally it's designed on peak loads. Now, the facade, before we sort of construct the facade, we normally test it. We test it for its performance from air, water penetration, structure, and whatnot. That's usually before the facade's installed, and we'll call it from day one. And we say, yep, take, air, take water, take da-da-da, great. And that's usually a 2.5 story by 3 panels wide, maybe a corner if you're lucky and able to get that. And that's made somewhere, in a test lab somewhere. And then we build this 60, 70, 80, 90-story building. And then what happens? It would be a good idea, Tim, if we went back to 171 and have a look at how the facade is performing over there. So really what we're saying is over time, there's no way that we really know, there's really not enough information about how the facade's performing over time. Bear in mind, I'm not talking about glass. There's a lot of technologies in glass. I'm talking about, and you get a facade system's pretty much been very similar. Maybe you want to say in the last 10 years, we've got thermal breaks, but I'm talking about the whole facade system with the glass in its operation, with the blinds, with the air conditioning system, all running together. So, as we all know, the facade's not static, it's dynamic, it's moving all the time. We always say it's a living membrane. And I've said that. We think, maybe if it's not broken, don't fix it. But improvements must be based on information and facts, right? So why I put the Eureka up there is because we did an inspection on the Eureka not too long ago, and we almost spent a month on this building going up and down. But really, what do we really get out of it? A little bit. We had gaskets missing, condensations in an IGU, gaps, cracks, delamination issues, and all that. That's great. Client can go there and fix all that up. But really, how the facade's performing, because Eureka is probably about 12 years old now, how that facade's performing compared to when it was tested and when the mechanical systems were all assumed from day one, nobody knows. We don't know, the client doesn't know. There's a building in the Middle East that, beautifully built, and the air conditioning system was not really working very well. There was some tests done to that, and found that the building was leaking quite a lot. So, and we found that the facade was a major contributor to that. So really, what we're doing is we're working on a remotely embedded, real-time monitored cellular-based sensor technology that we can actually get information 24/7, and we can actually monitor the facade performance and actually how it performs over time compared to its published data or assumed performances. Right, we then, the idea is over time we can actually analyze the data and use it in future developments. Now the area we're talking about is about solar radiance, cavities, you measure temperatures in and out, we can measure air leakages in the facade systems as well. Now, with this data, we can actually use and collect this information for future development. This is a typical curtain wall section here, and I'll just take, say, for example, a stack joint. And that's a section through a transom, for example, or a stack in this case. We look at incident solar radiation and transmitted solar radiation, so we can put a sensor on the inside and the outside. We can look at external wind pressures, the cavity wind pressures, and the air leakage by putting sensors in 3 different spots, for example. Surface temperature of the glass on the outside and on the inside. We can even put sensors into your pressure equalized zone and actually see how that is performing, surface temperature on the aluminum systems itself on the inside, again on the rain screen area and maybe somewhere there. And again, it's all tailor-made. Doesn't have to be as it is. It all depends on what information you want to get out of it, what we want to get out of it, what the mechanical engineer that we'll work with needs to get out of it. Now, again, that's a view on the inside, and we're looking at areas on where we're going to put this. We can put this on the sill, we can put this on the spandrel, so underneath the slab, just somewhere where we can actually house, well, you know, house the data logger. So these are just some of the equipments that we use or we've looked at. So again, the same issue, but just looking at it from, say, a cross-section through the mullion, for example, and having sensors in various spots to actually monitor how the facade system's performing. So the trick in this whole thing is actually the sensors, right? So again, we're not inventing any new technology here. These are all in the market. But again, we're putting it in, we're putting these sensors in areas that are hot, humid, and also not really accessible. So once we put the sensors in, it's really hard to get in there and pull it out if it fails. So really, the key to these sensors are it needs to be durable and long-lasting. It needs to be able to take extreme heat and moisture. It needs to be self-calibration as well because it's really hard to get in there. It needs to be accessible, so it's about how we actually make the hole in the system, get the sensors in there, and if we had to pull it out, we could do it, and also able to upgrade, so we can actually add more sensors, or if a new sensor comes up that's more up to date, we can actually use that, and also adaptable to 5G in the future. So really, what we're looking at is, say, you can have these sensors on various parts of the building, north, south, east, west, somewhere at the top, somewhere in the middle, maybe at the ground. They're all connected to a data logger. The data logger, in this case, can take up to 32 sensors for an area. That transmits through Wi-Fi to a cloud system, and that then comes back to us in the form of a dashboard, or even, not even, it comes back to the dashboard and also a phone-based app. So basically, you can have a look on your phone, and you can actually see how your building performs as it is, in real-time data. Now, having said all that, we're looking at gathering information over a period of 10 years. Roughly, that's in Australia, roughly 10 years is about how long we facade warranties, right? Not lifespan, facade warranties last. So the whole idea is trying to understand how the facade performs over time. So does it drop immediately from day one? Does it take 5 years and then starts deteriorating then? Is there a lot of movement? So really some of this information is going to be quite boring, because if you look at a 10-year span, then obviously you're not going to see up and down that much. So, but that's the idea, right? And then you can get all this information immediately and also historically on your phone apps. And that's really what we've got at this moment. So what you can do is multiple locations. So we've approached developers on multiple buildings, for example. It's all cloud-based, so we're working with a company that can provide all this security, and also the dashboard is tailored to the company that you're with. So a good company would be a big developer with multiple buildings, and universities. Obviously, they've got a big land stock. And again, dashboard, you can calibrate it to whichever way you want to give you the information that you want. So really what we're saying is smart reporting, saying what I've already said, tailor-make the information to suit what you need. We obviously know what we want from a facade design point of view, so we design facades to a certain extent. We put out specifications out there for facade contractors to meet, so we can actually tailor-make or amend or improve our specification that goes out there based on this information. So, and another thing about this is that it can be for new buildings and also existing buildings. The Census, it all depends on how much how much information you want. You can also add it along the way. And what we think the most important thing we'll get out of this is the historical data, right? So how it actually performs over time. So again, nothing new. We just think there's not enough information out there on facade, so i.e. glass and frames. And this allows us to actually monitor a facade 24/7. So what we're saying is information is king, obviously. It allows us to then, if you know what your facade's doing, then obviously you'll know, if you want to make any improvements, you know exactly what you're dealing with. Well, your improvements are fact-based, and they're not just guessing and assuming or assumption that we do. It's real time, and there's no more guesswork. One of the things that we think we get out of this is also you can actually predict if there's a failure going to happen. So for example, glass performance, if a glass is going to fail, obviously you can actually capture it if you can see the performance deteriorating because that it could be an air leak somewhere, and you'll see a drop in performance. So again, if you know what your facade's doing, you know how it's performing, you'll know how to actually look after your facade. Issues can be addressed quickly. So, thank you.
So thank you for the insight and putting the sensors on, and I got a couple of questions here. So if I've got a unitized curtain wall building with 5,000 units on it, how many of those units would you suggest to be monitored? And then how does it, and how do you bring it all back to the energy usage so that the owner of the building knows that the change in energy usage is either directly attributable to changes in the weather or changes in the facade performance?
All right, so the first one, I would say it all depends on how much, obviously these sensors cost money. Roughly, we looked at a set of sensors for about $8,000 or type of different measurements cost about $10,000–$15,000, right? And then there's also that ongoing cost of monitoring it. You know, where we come from, a good idea of north, south, east, west. I'll say somewhere at the top of the. It also depends on the type of building, and if it's a high-rise building, if it's a building in the city, if it's a hospital, it's a hard question. But I'd say if you took a standard box, I'd go different facades, potentially different facade types as well. Understanding there could be different glass in the building. You do somewhere at the top, somewhere in the middle, and somewhere in the bottom. So maybe about 10–12 sensors. That would be my. Now, the other one is the information. Obviously, we're thinking about how we want to use this information. Now, it's great to have this information, but we don't design the mechanical system. We don't design the lighting. Information like that's good. There's always assumptions. I know, if anyone here is a mechanical engineer, you always design the perimeter of the facade a certain way, and inside and outside and all that. One of the things Steve talked about the other day was about if you had a really good performing facade, your biggest challenge is actually trying to convince your mechanical engineer, because they always have something up their sleeve, right? And that's one of those things that, and the energy requirements are pretty high, but at the same time, they've always got something there, because to a certain extent, I can tell you now, a lot of them actually don't believe the facade actually performs the way it does. So by doing that, we can actually understand what comes through the facade. So air permeability is another one, for example. They actually underestimate how much air goes through the facade. That's one of those things that we find, and this will actually tell us. Again, when you do a test model, the gasket's new, the silicon's new, you're fitting it, the building hasn't moved. Air permeability, 0.03, somewhere around there. But over time, and I can tell you now, in our building that we're in, it's almost 50 years old, it's pissing air through. So, it gives that kind of information to building services, to be able to do what you have to do.
There was a lot of research being done in Central Europe about monitoring the performance of facades, like the data collection and so on. Now, your presentation was about what you are planning to do, so what you want to do. So do you want to come back after 2 or 4 years and present to the audience actually the outcome of the monitoring, so that you can see? So this would, I think, so you're planning to actually present then some outcome in the next GPD?
I think GPD is every 2 years, so 2 or 4 years is a very good one if you invite me back. But absolutely, you're right. In Australia, obviously, we don't have a lot of information. In Asia, we don't have a lot of information. And the answer is yes, it takes time. It takes a client that's committed as well, and that's why we've got some interest on clients who actually build and maintain their building. Right? The ones that build and sell, it's a bit hard. Universities are a good one because they have numerous buildings, and also, the super funds. In our case, the super funds and the listed companies, the listed builders, are the ones that would be interested in. So, yes, absolutely.
Hey, Oliver.
Hey, Rob.
Sorry, I've built up the courage to ask a question over the last time. So you're my guinea pig.
Just the last one before we go for the party.
So I want to get your thoughts on, we've got a few buildings where we have put some sensors in to try and monitor performance, generally thermal performance, thermal comfort.
Yep.
And one of the issues that comes up all the time is ownership and accessibility to that information. And you're talking about 10 years time of monitoring, and that's a lot of data to collect. So what are your thoughts on where that data sits and who owns it and who shares it? And as an industry, you can be very optimistic about this if you want.
No, it's funny. We had this the other day, and the same question was asked. The answer is I don't know. Right. It all depends on who's going to pay for it. Right. So right now, currently, the model is the developers obviously pay for it. They own the data. We monitor it for them because as developers, they may not know how to use it. With all respect to developers, and then but if we're involved in the job from day one, we can actually coordinate and work with all the mechanical and electrical engineers and make that data useful. We can keep the information for 10 years. That's not an issue. We can chop and turn it whichever way. So that's. But yeah, in terms of sharing the data, I think generally it's probably all right, but not in detail. Yeah.
Any other questions? Oliver, thank you very much.
Thank you.
Hi there. Did you like what you just saw? If you did, why don't you like the video, drop us a comment below, and share the video as well, since GPD is all about sharing. And to receive more videos in future, subscribe to this channel and don't forget to click the bell icon. Ciao!